Now we have a sealed container in question 3 with a volume of 2 liters, contains 2 atmospheres of dinitrogen pentoxide tetroxide at a constant temperature of 350 Kelvin. The gas decomposes into 2 moles according to the reaction. So I can see that 1 mole of this one forms 2 moles of this one. Based on the data, what claim can be made about the system? The equilibrium here is reached as the pressure becomes constant. I can see the pressure becomes constant after 80, 1.55, 1.55, and for the other gas NO2 also 0.090, 0.90. This means that the rate of the forward and reverse reactions become equal, right? We said that it becomes equal. From the table, the pressures remain unchanged between 80 seconds and 100 seconds. I cannot say that the system is at equilibrium after 60 seconds, because after 60 seconds, the pressure is still changing from 1.6 to 1.55. I cannot say the forward and reverse reactions are still occurring, but unequal rates between 60 and 80, because the pressure will become stable only after 80. The system is at equilibrium after 100 seconds because the forward reaction has stopped. This is incorrect. I can still see that they are still going. So they are still going, but at equal rates. So the only answer which is correct is B. Equilibrium is reached after 80 seconds because the pressure of both gases remain constant. It's not changing here. So this is B only is the correct answer. Question number 4. The graph above shows how rate changes with time for a reversible reaction. Which of the following is not correct about point A? Is it that the rate of the forward and reverse reactions remain constant, or partial pressures remain constant? The number of particles of each species remains constant, or you want to say that the concentration of reactants and products are equal? We need to focus in this question here because I can say that the correct answer actually is D. Yes, the rate of formation of product is matched exactly by the rate of the formation of reactants in the reverse reaction. So the overall concentration of reactants products don't change. Concentration does not change, which is why we say the concentrations are constant. So this is not the same as saying equal. Don't say equal, because concentrations equal means they are the same number, which is not necessary. So make sure that you differentiate very well in the exam between concentrations are equal or constant. Concentrations not necessary to be equal. The reactants and products might have two different concentrations, but the rate of the reaction will be equal and the concentrations will be fixed or constant. So the answer is D. Now let's go for the next question. Based on the data here, interaction between C2H6 and C2H4 plus H2, what claim can be made about the system here? Is it the equilibrium was established between 200 and 300? That's the reaction that forms C2H4 and H2 and occurs at 1 liter sealed container at 500. Initially, I have 0.050 of C2H6 introduced into the container. The following data shows that the concentration of H2 over time, what happens to it? Can I say that the equilibrium was established between 200 and 300? Can I say like that? Or can I say the forward and let's see 200 and 300 first. Between 200 and 300 is this equilibrium. The forward reaction stops after 300 seconds because of all the C2H6 has decomposed after 300 seconds. What happened after 300 seconds? I can see that the concentration of H2 is not changing. But is this correct? No, it's not correct. The equilibrium does not mean that all reactants have been used up. This doesn't mean that equilibrium. Actually, if all the reactant has been used up, this means that this is a irreversible reaction. So we cannot use irreversible reaction for equilibrium at all. Take care. The irreversible reactions cannot be used for the equilibrium. Equilibrium only in the reversible, in the two-way reaction. The equilibrium has not been reached because the concentration of H2 is less than 50% of the starting concentration. The equilibrium is determined by the constant concentrations, not by a specific percentage in which the reactants are transferred into products or converted to products. The last thing, it's not possible to determine equilibrium without knowing the concentration of C2H6. This is not correct, as we have enough data here to tell that the reaction is at equilibrium, as the concentration of H2 is shown. So I can simply say that the answer actually is A. But why is that? Because it clearly says equilibrium established between 200 and 300 seconds because the concentration of H2 stops changing after that. The concentration of the species remain constant because the forward and reverse reaction occur at the same rate. From the time is equal to 300, I can say onward, I can see the concentration of H2 remains at 0.027. So after 300, there is no change anymore of the concentration. This tells us that equilibrium has been reached since the concentration no longer changes. The next question, number 5. PCl5 changing into PCl3 and Cl2. One sample of PCl5 is introduced into a sealed container at 673, the above reaction occurs. So the PCl5 starts to break down into PCl3 and Cl2, and then they combine together again to form the PCl5. System is observed carefully to change in pressure and color and concentration. Which of the following observation would provide the strongest evidence that the system has reached equilibrium? How we will know that the system reached equilibrium? Is it A, the total pressure in the container increases steadily as PCl3 decomposes? If the pressure is increasing, so how come this will be equilibrium? Increase in pressure tells us the system is still shifting towards the products, right? I'm still making reactants or making products, but here it's decomposing, which means still making products. Is this rate of the forward reaction is not faster than the backward reaction, or is still faster than backward reaction? I mean, is not equal to the backward reaction. So this means that there is no equilibrium. The P says that concentration of Cl2 continues to increase. This is the opposite, which is still not equilibrium. At equilibrium, not all the PCl5 will have decomposed, but they will keep going both ways. Number C, the color of the system. The color of the system fades to colorless as PCl5 is converted to PCl3 and Cl2. Again, this is incorrect. Continued increase in Cl2 and decrease in PCl5 means that the system is still progressing towards equilibrium, not at equilibrium. When I say that there is equilibrium, it's the answer. The answer is D, because at equilibrium, pressure becomes constant. So the pressure becomes constant. There is no change in pressure. This is the correct answer D. At equilibrium, the forward and reverse action occur at equal rates and the pressure becomes constant. So the pressure will steadily increase as PCl5 is decomposing into two products. At equilibrium, the total pressure will eventually become stable finally. In this question, based on the data here, this is a reaction between C2H6 to form C2H4 and H2. Is asking that the following data shows the concentration of H2 over time. So try to answer and find yourself in the comments before I'm showing you the answer. So pause for a few seconds. Okay, based on the data, what claim can be made about the system? Equilibrium was established between 200 and 300 seconds because the concentration of H2 stopped changing. Looks like a correct answer, yes, because when I stop changing the concentration, the equilibrium will happen. The concentration of all species remain constant after equilibrium because forward and reverse reactions are occurring at the same rate. I can see from time equals 300 forward, there is no change in concentration. It is all the time 0.027 molars. This tells us that equilibrium has been reached since the concentration is no longer changing. Okay, what about B? B is incorrect. The equilibrium does not mean that all reactants have been used up. If you say that all the reactants has been used up, then you are saying that this is actually a irreversible reaction, and we don't have equilibrium in irreversible reactions. C, equilibrium has not been reached because the concentration of H2 is less than 50%. There is nothing that we took says that there is a specific percentage that you need to change the reactants into products by this percentage to say that this is equilibrium. We didn't say like that. We know it's equilibrium by constant concentrations, not by a specific concentration you reach. And D is not possible to determine equilibrium without knowing the concentration of C2H6. Actually, it's not needed because the H2 is stopping itself. So it's H2 is stopping, and this is a product formation. You can see the product formation decreasing or increasing or stop. So I will know that equilibrium has stopped. Oh, I mean, sorry, I know that equilibrium has happened.